Hello, this is part 4 of the Raspberry Pi War Tank project. This episode is more focused on testing rather than an actual function of the code. So, in today's episode, we have we have connected a motor, a DC motor, to the breadboard through an IC with a lot more wires now added to the breadboard. There's also an external power module connected to the breadboard as well, because the Pi itself doesn't have enough power to power the motor. Now, some issues that I ran into. Previously, I had the freenove kit DC motors connected to the tank, as you can see right here. I haven't replaced this one yet. However, when I ran this through the code and had it connected to the track, it didn't move. And I thought that I did something wrong with the code, or that this doesn't have enough power. So I removed the track, I removed the wheel, and I ran it by itself, and it worked just fine. I touch it with my finger and it stops running. That's how weak this motor is. So even for the official testing, the tank is gonna be jacked just like this approximately, so the track would stay in midair, because I don't think that this motor has enough power to move the whole tank as well. But anyway, so yeah, I had to replace these motors with some stronger ones. I have this one and this one right here. These motors don't come with the freenove kit. I got these are just scrap. They were from an old printer. We had dismantled the printer and I collected the motors in case I needed them for something. So I have like 5 of these motors. And would you look at that, they came in handy just now. Because these have a lot more power than the freenove DC motor. So yeah, that's basically it. I have successfully connected the motor to the IC. The IC is successfully connected to the Raspberry Pi, and the module works as well. So to activate the module, first you need to press the button, and you'll see the green LED. That means that power from the battery is being transferred to the breadboard. Now if I run the code, by the way, this is testing code, so the joystick and the servo motor don't work. The servo motor is disconnected because I had to flip the tank upside down to be able to remove the bracket of the old motor, and enlarging it to accustom the new motor. So yeah, if I press F5, hopefully it works. There we go. It is coded that it will move forward for 10 seconds. This is also controlled via PWM. This is 100%, so like this is full 5 volts. This outputs a 5 volt current. So this is like the maximum power it can get with 5 volts. So yeah, that's basically it for this episode. If we run it again, because it is quite satisfying seeing the track move successfully. So this is how the testing is gonna be, because a main problem is, since I have changed the motor, as you can see, the new motor is a lot larger than the old motor. So, oops. So if I remove the jack from its place, I can still freely rotate the track, because the motor is larger than the entire track. So the track is now in midair. So honestly, I don't think I need the jack anymore. Hold on, if I run it like this, what will happen? Oh, let me select the code, F5. Yeah, okay. I don't even need a jack. It just runs freely at this point. Yeah, okay. So I don't even need a jack, apparently, because the motor is so large. I would have needed larger wheels, but I don't have larger wheels, unfortunately. So it's gonna have to stay like this. Okay, so yeah, basically next part, for next episode, I'm gonna replace the second motor with this, and I'm gonna hook it up to the breadboard as well, and I'll try to get them both working. So next episode will probably just be another testing of this motor and having them both work simultaneously. For episode 6, I'll try to connect it to the controller, to the joystick, and we'll see how that goes. Alright, so that's all for this video, and I'll see you next time. Bye bye!